Welcome to this highly critical technical session focusing squarely on implementing responsible AI across generative AI and agentic systems. Let us learn how to secure your enterprise models. Welcome to this highly critical technical session focusing squarely on implementing responsible AI across generative AI and agentic systems. Generative artificial intelligence represents one of the most profoundly powerful advances in technology ever conceived. It empowers software developers and enterprise architects to build sophisticated applications that seamlessly consume machine learning models, which have been extensively trained on a massive volume of data from across the internet. These models can generate dynamic, highly contextual new content that is frequently indistinguishable from content meticulously created by a human expert. However, with such unprecedented and powerful capabilities, generative AI brings with it some very severe inherent dangers. If left entirely unchecked, these models can confidently generate harmful, biased, offensive, or factually inaccurate content that can severely damage your enterprise reputation. Therefore, it absolutely requires that data scientists, application developers, and security architects adopt a highly rigorous, responsible approach that actively identifies, continuously measures, and forcefully mitigates these exact risks. Microsoft has established a highly actionable, comprehensive four-stage process for responsible generative AI that builds directly upon Microsoft's foundational responsible AI standard and corresponds very closely to the rigorous functions outlined in the NIST AI Risk Management Framework. The four critical stages in this iterative process are map, measure, mitigate, and manage. You must aggressively map the potential harms relevant to your solution, rigorously measure the presence of those specific harms in your generated outputs, implement robust mitigation strategies across multiple architectural layers to minimize their impact, and responsibly manage the deployed solution through continuous operational readiness plans. Today, we will deeply explore exactly how to configure these safety filters, enforce strict guardrails, detect risks, and implement robust content moderation to ensure your enterprise AI applications remain completely safe and highly reliable in production. This JSON representation outlines the four foundational stages of Microsoft's responsible AI framework. Following this structured iterative lifecycle ensures you actively address security at every phase of your project. This flowchart visualizes the continuous, iterative, responsible AI lifecycle. The absolute first stage in successfully implementing a responsible generative artificial intelligence process is to rigorously map the potential harms that could uniquely affect your specific planned solution. You cannot simply apply generic security templates. You must understand your exact risk profile. The mapping stage consists of four sequential, highly analytical steps. First, you must explicitly identify the potential harms. For example, a medical advisory agent carries vastly different risks regarding physical harm than an internal IT help desk bot. Second, you must aggressively prioritize these identified harms, based entirely on their potential severity and their statistical likelihood of occurrence in the real world. Third, you must actively test and empirically verify these prioritized harms against your initial model prototypes. Finally, you must comprehensively document and share these verified harms across your organization. A critical best practice here is creating a formal AI impact assessment. This vital document meticulously records the exact business purpose, the expected user interactions, and the specific potential harms for the solution, ensuring complete architectural transparency. Once you have successfully mapped your risks, you transition directly into the measure stage. In this phase, you systematically establish a concrete performance baseline and define a repeatable, mathematical way to measure the exact frequency and severity of the harmful outputs actually generated by your solution. You achieve this by establishing comprehensive testing datasets filled with intentionally provocative or ambiguous prompts, and then programmatically running these datasets against your model. By thoroughly mapping your unique threat landscape and objectively measuring the model's baseline behavior, you establish the exact data-driven foundation required to design highly effective, targeted safety guardrails and robust content moderation filters in the subsequent mitigation phases. This Python snippet demonstrates the measure phase. By running a dataset of intentionally provocative prompts through an automated evaluation SDK, you mathematically quantify the model's baseline defect rate for severe harms like hate speech. This diagram details the map and measure workflow. After determining a solid baseline and establishing a reliable, objective way to measure the harmful output generated by your system, you can finally take decisive architectural steps to mitigate those potential harms. Mitigation of potential harms in a generative AI solution absolutely must involve a comprehensive, defense-in-depth, layered approach. You cannot rely on a single security filter. In Microsoft Foundry, these mitigation techniques can and should be actively applied across four distinct architectural layers: the model layer, the safety system layer, the system message and grounding layer, and finally, the user experience layer. Let us briefly examine the model layer first. The model layer consists of the actual foundational generative AI models at the absolute heart of your solution, such as GPT-4. Mitigations applied directly at this foundational layer include purposefully selecting a model that is perfectly scaled and appropriate for the intended use case. For instance, if your application only needs to perform simple text classification, utilizing a massive, highly complex model unnecessarily increases your risk surface. A simpler, smaller model provides the exact required functionality with a significantly lower inherent risk of harmful content generation. Additionally, you can aggressively mitigate risks at this layer by fine-tuning the foundational model with your own highly curated, sanitized training data. This ensures the model's generated responses are far more likely to remain strictly relevant and safely scoped to your specific business scenario. The user experience layer, at the top of the stack, involves designing your application interface to clearly inform the user that they are interacting with an AI system and providing mechanisms for users to flag inappropriate responses. In the following slides, we will dive deeply into the two most critical middle layers, configuring the active safety system and enforcing strict behavioral guardrails through system messages. This configuration object explicitly outlines the 4 layers of defense in-depth mitigation. Relying solely on prompt engineering is dangerous. True security requires integrating controls across the model, safety system, system message, and UX layers. This architectural stack shows the 4 mitigation layers. A user request passes through the UX, is shaped by the system message, filtered by the safety system, and processed by the model. The most critical technical control you will configure to protect your generative AI solution operates at the safety system layer. What exactly is the safety system layer? It is the robust, highly intelligent infrastructure deployed directly by Microsoft Foundry that sits seamlessly between your end-user application and the underlying foundational language model. One of the absolute most effective ways to aggressively mitigate harmful responses from generative AI models is to deploy and configure strict guardrail controls at this precise layer. These guardrails act as a highly sophisticated, real-time natural language firewall. When a user submits a prompt, the safety system's content moderation filters instantly analyze the text. If the system detects malicious intent, such as a coordinated jailbreak attempt, hate speech, or requests for restricted materials, it will immediately intercept and completely block the request, preventing it from ever reaching and consuming the expensive compute resources of the core model. Furthermore, this protection is entirely bidirectional. Even if a safe prompt somehow causes the language model to generate a toxic, biased, or inappropriate response, the outbound content filter will catch the violation and forcefully block the output before it is ever delivered back to the client application. By actively configuring these safety filters and guardrails, you ensure that your system programmatically prevents the output of harmful content, regardless of how unpredictable the user's input might be. This infrastructural mitigation is simply non-negotiable for any serious enterprise deployment. It rigorously protects your organization's brand reputation, absolutely ensures strict compliance with corporate acceptable use policies, and actively saves you from wasting your financial budget on generating toxic or malicious token sequences. Always ensure you extensively test these guardrails in the Azure AI Playground by intentionally submitting challenging edge case prompts to verify that the moderation filters catch and log the prohibited content accurately. This critical error handling logic demonstrates the safety system in action. When a user attempts to bypass security, Azure intercepts the prompt and throws a content filter error, which your application must catch, safely log, and handle gracefully. This visual demonstrates the bidirectional content firewall. Inbound prompts are actively scanned for toxicity. While infrastructural content filters are essential, you must also enforce strict behavioral guardrails closer to the model itself. This occurs at the system message and grounding layer. This critical layer focuses heavily on the meticulous construction of the prompts that are actually submitted to the generative AI model. Harm mitigation techniques applied at this layer are highly effective because they explicitly dictate the model's cognitive boundaries. First, you must aggressively utilize system messages. A system message specifies the foundational inputs that define the exact behavioral parameters, professional tone, and strict output formats for the model. By explicitly telling the model what it is not allowed to do, and by establishing a firm when unsure policy, such as commanding the model to confidently state "I do not have that information" instead of attempting to guess, you drastically reduce the risk of dangerous hallucinations. Second, you must heavily rely on prompt engineering to proactively add verified grounding data to your input prompts, which actively maximizes the statistical likelihood of a highly relevant, completely non-harmful output. For enterprise applications, the ultimate grounding guardrail is implementing a retrieval augmented generation, or RAG, architecture. By using a RAG approach, you force the AI agent to retrieve factual, contextual data strictly from your trusted, internal data sources, like an Azure AI Search Index, and explicitly include that verified data directly in the prompt payload. This firmly anchors the model in reality, ensuring that every generated response is verifiable and backed by authorized corporate documentation. Combining strict, boundary-setting system messages with enterprise data grounding creates a remarkably resilient AI agent that safely ignores out-of-bounds requests and never improvises critical business facts. These strict system instructions form an unyielding behavioral guardrail. They tightly scope the agent's persona, explicitly forbid dangerous topics like medical advice, and mandate a secure fallback response to entirely eliminate hallucinated answers. This diagram illustrates the system message and grounding layer. The user request triggers enterprise data retrieval, which is combined with strict system instructions to compile a grounded payload, ultimately yielding a safe, factual response. Finally, after configuring your safety filters and implementing robust prompt grounding, you reach the fourth stage of the responsible AI lifecycle: manage. To successfully manage a responsible generative AI solution over the long term, you must proactively define and strictly follow a comprehensive deployment and operational readiness plan. You cannot simply release a generative AI agent to your entire global workforce overnight and hope your guardrails hold. Instead, you should always rigorously consider a phased delivery plan. A phased delivery plan involves releasing the solution to a small, highly controlled pilot group first. Why is this absolutely vital? Because a phased rollout enables you to safely gather critical real-world feedback and actively identify unexpected behavioral issues or missing knowledge gaps before releasing the solution more broadly across your enterprise. During this pilot phase, you must obsessively monitor your live operational telemetry. You should track exactly how often your content moderation filters are successfully intercepting toxic prompts, and actively use automated evaluation metrics to continuously measure the groundedness and relevance of the model's outputs. If your monitoring detects that users are repeatedly attempting to bypass your safety guardrails, or if the model begins to drift and hallucinate, you must immediately use that data to iteratively refine your system messages and tighten your safety filter configurations. This relentless cycle of monitoring and improvement ensures your AI system remains permanently secure. Security in the age of generative artificial intelligence requires relentless vigilance, and mastering these four stages: map, measure, mitigate, and manage will set you apart as a top-tier Azure AI architect. Thank you for joining this deep dive. Please be sure to like and subscribe to our channel. For premium certification prep, including massive Q&A banks, comprehensive ebooks, expert audiobooks, and exclusive interview guides, absolutely visit quicktechie.com. Build responsibly. This configuration models a phased delivery rollout at the infrastructure level. By routing only 10% of traffic to the new pilot agent, you can safely monitor edge cases and validate guardrail performance before a global deployment. The continuous management lifecycle. A phased pilot release generates live telemetry.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.